We're doing now is called integral calculus, and that deals with what we call integration. And you'll hear another term, that's the antiderivative. Some people say antiderivative. So antiderivative simply means that we are doing the opposite of what we're doing when we're differentiating. So to understand integration, we must first look back at what differentiation is. So let's look at the power rule for differentiation. So we have a function, let's say we have, let me get the right, of d dx ax to the n power, where a is a constant, right? So a could be 5, 4, whatever. What would be our answer, or the derivative in this case, if we have ax to the n power? If we're differentiating, what will be our result?
Sir, n multiplied by a multiplied by x to the n minus 1 in the power.
So we multiply by the power, basically. So it will be n times a, very good, back with our x to the n minus 1 power. So basically we do two things, right? We multiply by the power and we subtract 1 from the power. Isn't that so?
Yes, sir.
Good. So that's what differentiation is all about. Now, integration will undo differentiation. That's what integration does. It will undo differentiation. So let's look at this. So if we have a function, and this is the symbol for integration, this tells us that we're going to integrate. So this is the symbol you're going to see. So we see the integral of a to the ax, to the n power. Let's think about all we did up here and do the opposite. So instead of subtracting 1 from the power, what would be the opposite of subtracting 1?
That's what.
Adding.
Excellent. Right? Now this dx is important here because this is saying we are integrating with respect to x. So we are focusing on x and its power. Right? If you see dt, it means we are integrating with respect to t. If you see dr, we're integrating with respect to r. Right? And you will see some of these coming up very soon. Where you wouldn't see dx, you might see dy or dt. Right. So we agree that the opposite of subtracting 1 would be adding 1. So if I wanted to integrate, this is what I would have. Ax to the n plus 1. Are we good so far?
Yes, sir.
So when we're integrating, we'll do the opposite. So we'll add 1 to the power, and when we were differentiating, we multiplied. What will we do in this case? We are dividing, but we are dividing by the new power. So my new power would be n plus 1. Is this good with everyone? First time? Or friends from Noob Center? Welcome. Thank you for joining us this evening. We covet your participation. Good. So there's one thing that we need to add here, and that's a constant. So whenever we integrate, we add a constant, and I'm going to explain why we add this constant with an example. So once you integrate, make sure you add a c. You just put c for the constant. It could have been anything, but the the customary thing to put there is c, probably because c begins the word constant, right? So it's called the constant of integration, and I'm going to show you why that's important. One thing that's really useful, right, is for us to remember in our own words. I think I said this to us before, what the process is. So for integration in their own words, basically two things you have to say.
Sir,
So
so basically doing a reverse differentiation where we add 1 to the power and the new power we divide it by ax.
Very thank you, miss. We add 1 to the power and we divide by the new power. That's it. Once you have that in your head, then you have conquered integration in most respects. But this is integration for the power rule, right? So let's look at some example action time. So I'm going to do one and I'll give you a few to do. So let's say we're asked to integrate 3x to the second power with respect to x. So our answer would be 3x to the second power. According to the rule, we add 1 to the power and we divide by that new power, which is 2 plus 1. I'm just dragging it out and I add my constant of integration. Any questions so far? The 3x cubed over 3 plus c, and that will give me, so I can cancel out here, x cubed plus c. This is good with everyone. When you're integrating, you're like a detective. Because this function, you want to know, what was the function I had before this function here? Which function gave me 3x squared? Which function did I differentiate to get 3x squared? That's the question you're asking yourself, right? So you're like a detective. Okay, the evidence is that there is a 3x squared here. And so what function did I differentiate to get 3x squared? So your answer is, this is the function I differentiated. So anytime you're integrating